in Canada because...
A boot! Not a boot. Sorry.
Hey, welcome back to Trail Trash Garage with Jeff. Hey, we're working on a new project today. And you can probably see it to my right a little bit. And so I'll introduce you to that project. I know I got a lot of projects going on, but this is a DRZ, 2001 DRZ 400. It belongs to a guy that we ride with here in the valley. And he was riding and lost the screws in the stator. It's a dreaded not enough Loctite or no Loctite on the stator retaining screws. So he ordered a new stator, replaced it, and he now has no spark issue. So we're gonna have a look at that today. We're gonna be testing some electricals. I kind of started this and so I'm just gonna cover what I've done so far. There are better tutorials for what I know. I always say that a lot, but there are better tutorials out there for what I'm doing, but I'll just quickly cover it. Doing a quick search YouTube, there's not really anybody that's really talking about this unit specifically. And when I say this unit, I mean testing the charging system and ignition system specifically, not necessarily the charging system on a DRZ. There's a few out there testing the stator. There's actually probably a DRZ400 Stator video, you know, test wise, replacement. And I think there's even one that talks about, one or two probably, just in my quick search, that talks about the Loctite issue. And I think there's an Australian guy or New Zealand guy, judging by the accent, that goes through from start to finish on just doing a checkup on that. I don't know if I'm going to have to get into the stator at this point because there's only a few things that we're going to look at. So we're going to look at some of the basics on, you know, why your DRZ won't start. We'll test the coil, the spark plug, and a few other things like that. And actually a couple of those I've already done, and we'll talk about that. So let me quickly, I'll introduce you to this. I'm going to take you off of here. So here's our 2001 DRZ. We got an aftermarket, I think it's a Clark tank. He hasn't got that on right now. There's a few things, and here's the issue when you're getting into electrical problems is you got to go over and you got to think about, okay, what's been done already to this. Okay, this is a switch that shuts the light off. It's an override switch for the headlight. For whatever reason, the owner decided to put the cutoff switch just to be able to shut the light off when he's driving during the day and doesn't need it. That would free up wattage for heated gear. When I don't know if he's running, I don't see any charging ports or anything else that you know, lets me think that he's running that stuff. As you can see, he's gone to LED blinkers, and there's a few things we need to just fix up down here. Just a few things. So basically he has tried to repair this himself, and you know, he wanted to repair it himself. And he just kind of got in and got frustrated and reached out to me to see if I would have a look at it. Electrical isn't my favorite, but I am getting slightly better at it every time I tackle one of these issues. So we're just going to see, we're going to go through in a methodical way and see what we can do. I am just getting over COVID, so my voice is still not quite there. We had quite a sore throat. So we're going to go through this methodically. I have got an app on the phone. It's called the DRZ400 Companion, developed by Emilio Gaines. I'm not taking credit for that. So it's basically an app that has the owner's manual, service, maintenance schedules, and it does have the factory service manual. So in going through that factory service manual, it's going to give us, in that factory service manual, it gives us specs for testing some of the equipment that we're testing. I'm going to take you through some of the things that what I've started. First off, I'll demonstrate the bike. So what we have here is we have a starter moving, but we got no spark. So the first things you need to check on that condition is your safety switches. Those things are the ones that are going to get you out of the running altogether. So the clutch safety switch, you just disconnect it. It's got a male and a female bullet connector, and you can connect them together at the harness level, and that basically shorts that out and makes the bike think that the clutch has been engaged. So the bike, if you hear, so it's going to turn over without the clutch in. Second thing I've done is somebody had spliced into, this is the safety switch for the kickstand, okay? Bang, bang. And somebody spliced into it. So I cut with just crimp connectors, and I'm not a big fan of crimp connectors. So I cut them off and temporarily just bypassed the switch. So the switch housing is down in there. It's been tucked in. But basically, again, you twist the wires together, and I didn't make a permanent connection because the owner's probably going to want that hooked back up. So I'm going to make a good connection, not with just crimp, but a good soldered connection back to that switch. A lot of people disable those switches because they do fail and they'll leave you stranded in the woods, but it was hooked up when I got the bike, and so I'm going to give it back to the customer, or not the customer, but I'm going to give it back to the owner, you know, hooked up the way it was. Just all I'm doing is swapping out a butt connector, crimp connector, for a soldered connection. So the other safety switch you have is a neutral safety switch, and I verified that that works. And how you do that is it's described in the manual by pulling the plug off the ECU, okay? This one needs to be pulled too, but not for this test. So here you've got the black, or the orange and white wire, and the black and white wire. The ECU should be getting power under certain conditions and not under certain conditions. So the troubleshooting for no spark manual will get you to try it with the neutral and without the neutral, and with the switch on, the run switch on and off. Make sure that you're getting power to the ECU through the ignition switch, okay? And the run stop. So that kind of tests this switch, and it kind of tests the neutral safety switch, and just making sure that the ECU is getting power from that. Hey, so editing the video, I realized I didn't explain this very well. So basically, you're going to follow any instructions that are in your troubleshooting guide within your manual, and I highly suggest you have some manual. Either it's a factory service manual, or Haynes or Climber's manual to go with your bike. In this case, we're using an app, the DRZ Companion. You should be getting power to the ECU when the key is on, and when the neutral switch is in neutral, and the engine stop switch is in the run position. And you shouldn't be getting power to the ECU when one of those conditions is not met. And I didn't really explain that real well, so I just wanted to clarify that. So again, power to the ECU on that main 12-volt line, you should see 12 volts at that line, and I'd have to recheck the manual whether it's the orange line or the black, but I'm going to go out and say it's probably the orange. So the neutral switch needs to be in neutral. If the neutral switch is not neutral, you're not going to get 12 volts to the ECU. Ignition needs to be on, or you're not going to get 12 volts to the ECU, and the engine kill switch needs to be in the run position, or you're not going to get 12 volts to the ECU. So you want to check both states to make sure everything is fine in that state, and then you can move on with your troubleshooting. Back to the video editing. So that's where we kind of left off. Well, no, I should say that I did pull the spark plug out, and I checked the spark plug that's in the bike. And it does have spark. So, and I tried another plug that does have spark in that, and it didn't work. Okay, so now that you're set up over here, just to show you really quickly, the coil is off the bike, and we just test the coil. So we take our multimeter here, we set it on the ohm setting. And I believe the spec on the book is 0.0 something to 0.1, and we were like 0.8, so we were within spec. So we need to go up to the 20K. Okay, and let's go back in here, and because we should see a huge resistance. So that's 16K, or 164. I guess it's going to settle down there. Ohms. So why we're seeing a high resistance rate there is because there's a resistor in this cap, okay? So again, primary side we had 0.01 to 0.1, which we were 0.8, and the secondary coil had 12 to 20 kilo ohms, and we were at 16.5 kilo ohms. So that coil checks out in spec. Now the only thing with this is coils, again, can go out of spec when they heat up. But we're not concerned about that here because we have no spark issue when it's cold. Okay, so where he had the stator replaced was the last thing he did, and now he's had a no spark issue. The next place I went after confirming that this was working, all the safety switches were working, and the spark plug was good, was the igniter coil. And it's called different things. It's called a pickup coil, igniter coil. There's a few different terms for it. Just I have had to do a little research on this particular setup, and I guess this is where the confusion comes in, just because we have 4 wires that come up to the CDI unit. And I'm back again. So editing the video, I realized that I talked about this is where the confusion sets in, and then I moved on and started talking about a test that I'd performed, and I never really explained why the confusion. So just to kind of clarify that, so there's a bunch of interchangeable terms for the part that we're talking about. Some places call it a pulsar coil, a starter coil, crank position sensor, or what have you. So, but basically what it is a sensor that sits on the flywheel, and when the flywheel comes around to a certain point, then it tells the pulsar coil to send the signal up to the ECU to send the signal over to the ignition coil to fire the spark plug, right? So it's all about timing. So there's a magnet on the flywheel. Of course, the magnets on the flywheel rotate around the coil windings for the stator, and that magnetic field creates AC electricity, which goes up to the regulator rectifier to get converted to DC and then to charge your battery. Well, on that same flywheel, there's a magnet at a certain position on the flywheel, and it's always marked on the flywheel. And when it comes around to that crank position sensor or pulsar coil or whatever it is, right? Then it sends that signal up to the ECU. The confusion is that most of the time that's a 2-wire sensor or / coil. The DRZ manual refers to it as a signal coil, and then the pickup coil. So the pickup coil is what we're testing, but we're also testing this signal coil. And I will admit, I'm not 100% sure what the signal coil does, and I looked through the manual. I couldn't really find any reference to it. I've done some snooping around on the internet. However, as you'll see in this test that we're about to cut to, that signal coil tested within spec. So I kind of moved on from there, and I need to do some further research, because obviously at the time of this editing I don't have this problem solved, and the video series will get into a couple of reasons why, but suffice it to say, the signal coil, the black and white wire on that 4 connector on the DRZ, it tested within spec, and the blue and green wire, which is the pulsar coil or the pickup coil, does not test within spec. So we'll get back to the video. So there's a pickup coil and a signal coil, and that's the test that I did the other day. So I'll set you up over there and I'll repeat that test today, because I'm actually going to repeat it on my bike and see if we get the same thing, and I'll explain why. So this is the next procedure in the no spark issue, okay? And so remove the CDI cover, disconnect the generator coupler, measure the resistance between the lead wires using the multi-tester, and the resistance is not within spec value. The pickup coil and signal coil must be replaced, okay? So when you replace a new stator, when you buy a new stator for these, it comes with the pickup starter coil already, okay? So that should be new. So your 3 wires here, that block, okay, that comes off of the stator and runs to the regulator. These are the 3 AC wires, and then your regulator has to convert that to DC, and that sends it up to the battery for charging. Those coils tested out fine. So the stator coils are within spec, okay? And if you want, I'll go over that real quick afterwards. But basically here is the signal coil and pickup coil. And again, I'm not 100% sure why those 2 are separate on this bike. Usually it's the same thing. The ECU is getting powered from the battery through this power line. So in ECUs that don't, There are some ECUs that get powered directly off the stator. So there's a power line and then there's a signal line. So, but basically the pickup coil and the signal coil, or the pickup coil traditionally tells the CDI unit when to send fire to the coil and spark plug, you know, and that's all based on timing. Now, I don't think, I've never had the side off a DRZ, but in my research, it doesn't look like there's any way to really adjust that. Now, there's usually a gap between the pickup coil and it's not a commutator, it's another plate anyway that triggers the signal, or yeah, triggers the signal. It triggers the pickup coil, and there needs to be a specific gap between those two, between the rotor or flywheel, or what, you know, it's called different things. But basically, the sensor sits here, the rotor spins here, and there needs to be a certain gap there. But it doesn't look like this is adjustable. Like it's a fixed point. And nobody in any of the replacement videos or anything that I've watched talk about needing to adjust that or anything in this. But again, I've never had the side off of here yet. I haven't tried, I haven't looked at mine or had anything else. So just in an attempt to, you know, go over the basics and go over the simple things here, in diagnosing this no spark issue, we're going to go ahead and test this out. So it literally says pickup coil resistance. Pickup coil is blue and green, and the value should be between 390 and 600 ohms. Okay, so in that case, because 390 and 600 are both over our 200, if we go back to say 2000, and we need 390 to 600, okay, 205 or 0.2 kilo ohms, 205 ohms, that's well below the 390 ohms. So what does that tell us? Well, it's out of spec. Now, it's not an open line, so there is a connection there, and it's not too high of a resistance, it's too low of a resistance. So I'm not exactly sure. Again, this is where my weakness in electrical matters comes out. But basically, we'll test that again. Yeah, we're constantly 205. So let's test the other one, then I'll explain why I want to test my bike. So again here, signal coil resistance. So that should be 0.05 to 0.2. So we're going to go back to 200 because that's well below. And that's below ohms. So we're going from black to white here. And we've got 4.5. So that is way above 0.2, which is our high end. So yeah. So right now this is testing out of spec. He didn't buy an OEM stator, he bought an aftermarket stator from Fort 9. So I don't know if that pickup coil / signal coil is still the same spec that the manual is giving me on an OEM. A common resistance value for a pickup coil, like in a lot of Chinese engines and a lot of other Japanese application engines, is 200 ohms. Is usually, you know, they're 200 ohm pickup coils. So I don't know if whoever made this stator, you know, used a 200 ohm pickup coil. And to be honest, like you know, I don't know enough about this stuff. On full disclosure, I don't know enough about this stuff to be able to know that even that's even possible. So would a 200 ohm pickup coil / signal coil be just fine for this, even though it's not the original spec? You know, is that an acceptable pickup coil? I'm not sure. You know, all it needs to do is, as far as I know, send a signal up here to tell the CDI when to fire the spark. So we're going to go over to my bike and we're going to test it, and we'll see what we're going to see. What's the other one I'm going to need to set that down for? So blue and green. So 460. Okay. So that's within spec. Okay. So let's drop back down. Let's come over to black and white. Okay. 0.5. So that is actually above. That's almost what the other one was. So that's actually above spec. .5. Now, the spec is 0.2. There is some variance in these. This is an old multimeter, so there is a chance that I'm actually close. But that would mean that one over there is fairly close too, because I think we were getting was it 0.5 or 0.6? So that side might actually not be bad. So that was the signal coil. So it's just the pickup coil resistance that is out of whack on that one over there. So what does that mean? I don't know. It may mean that we need to replace the stator again. The stator he bought was bad, or it was damaged during installation or something. So I dug up my other, my new volt multimeter. I just picked it up. It's got the settings are a little different. So my old trusty one, I tend to dig out first sometimes, but anyway, I wanted to verify that test, and it is the pickup coil is dead on 200 ohms. And when I test the other side, this meter reads at 0.3 or 0.2, which 0.2 is the upper limit. So it probably just is the variance. So I'm assuming that the signal coil is within spec. Now, that pickup coil spec being out of spec, again, it doesn't. It's really throwing me for a loop, because if it was any other number than 200 ohms, then I would say okay, it's out of spec and it's not right. But where a lot of pickup coils, in my limited knowledge, there's a lot of pickup coils out there that run at 200 ohms, and this is an aftermarket stator and an unknown pickup coil. It's just, that's too much of a coincidence for me to have it at 200 ohms and then have that be a typical number for a lot of pickup coils. So I can't count that stator out at this moment. So I'm going to look at other solutions. I got to do some research on this one, so I'll probably bring you back after I do, but I'm just going to mention it. The next direction I'm going to go, I think there is, in this turn signal relay, there is also a kickstand switch relay. So I don't know if just crossing the kickstand switch in this bike is enough to that's what most people do to bypass it, but reading in the manual, there's something there about a relay. So I'm gonna have to double check that. So we're gonna do a little research, and I'll come back to you or bring you back when I figure that out. Before I let you go on this one though, I'll try to get as much done today as I can, but it's cold in the garage and I've only got so much time. But there's going to be a few other things done to this bike. Once we get the spark issue solved, we have new coolant pipes. There's a silicone coolant pipe kit. The other reason this bike has been parked for a little bit, the rear brake line has collapsed internally, so it'll let fluid through and clamp the rear brake on, but it won't let it through. So I've got a new stainless, the owner bought a new stainless line for the rear that we're going to be changing and bleeding. Yeah, there might be a couple of little odds and ends we're going to do. I'm not 100% sure. So we're going to make a little series on this bike, just like we did the 250 XT refresh. And then we're still doing the gull wing. There's that I just filmed a segment on that yesterday. So, and for the third time, we're back in the editing room. So the footage pretty much ends there. We don't move on until some time later. The recommendation to the customer was to order a new stator. We kind of talked it over, and Tim decided to order a new stator. We didn't order. He tried to return the one that he got, but because he'd ordered it, bought it, and then the bike sat for a few months before he got around to getting that stator installed. The supplier or the store he bought it from just wasn't interested in doing an exchange or a refund. So it sucks, but he went ahead and ordered a new stator to come in. So there's always a little bit of variance between testers. Like I pulled out both of my multimeters just to kind of verify things. The manual, Suzuki manual, specifies certain ranges for those tests, but the leads on the multimeters themselves have resistance. So when you're doing ohm tests, you do have to calculate in a little bit of resistance for those leads, and so that easily could make up the difference where we were a higher resistance on the signal coil. That's the black and white wire. So I think they read 0.5 and or 0.6. I think my bike was 0.5 and Tim's was flopping between 0.6 and 0.5. And the upper range was 0.2. And when I retested with the newer multimeter, I think I was down to 0.3 and even 0.2. It kind of flip-flopped between the two. So that's well within spec because those leads are going to have some resistance of their own. And at that low settings, at the below 1 ohm, you're definitely going to see that the resistance creep up there. So without rambling too much more, there's more to come on this project. Again, like I stated earlier, it's not quite finished yet. We went on ahead and did some other stuff, and so you'll see that in the next video. But for now, if you want to watch me stumble through electrical and make a fool of myself, and stick around, like and subscribe. And for Jeff at Trash Garage, I'll catch you in the next video. You know we're in Canada because
a boot. Not a boot. Sorry.